Hey everybody, welcome back to Organic Chemistry. My name is Todd Rothman, and in this video we're going to go over section 3, which is naming stereoisomers. So how do we name them? Well, if you remember, the idea with our hands is that our hands are mirror images of each other, but yet they're not superposable. So our hands are enantiomers. That's the relationship between our hands. Now, how do we identify our hands? We say we have a left and a right hand. So left and right is the identifier for our hands. Well, when it comes to molecules, the way that we identify one mirror molecule to its other mirror image that's not the same is R and S. So instead of left and right, we use R and S. That's the identifiers. So let's talk about how to identify. Now, the thing is that we're going to come up with these rules, and then I'm going to show you practice using these rules, and then you're going to try a bunch of problems on your own, and we'll go over them as well. So just bear with me, and you're going to get the rules down. It's going to make sense. Let's go through it quickly. First, the ideas of the rules itself. So I'll use as an example, I'm going to use a molecule. Like, for example, I'll use, I guess, this right here. This will be my example that I'm going to use. So let's go ahead and look at the rules. The first thing is that you want to find your stereocenter. Look for your chiral carbon. You have to find your chiral carbon. And this is really about chiral carbons, okay? But actually, I'm not going to write chiral because we're going to learn something a little bit later on that kind of changes this a little bit. But stereocenter is the right way to say it. Look for your stereocenter. And in our example, that is right there. This is the carbon that's chiral. It has 4 different groups. It has an ethyl. It has an ethyl that's double bond. That's called vinyl. It has a methyl and an H. So there's my chiral carbon. Now, the next thing is that we want to look at the direct attachments to our chiral carbon. And we ask ourselves who has the higher and who has the lowest atomic number. The lowest atomic number has the lowest priority. The highest atomic number has the highest priority. So here's like a little trend that you can remember for atomic number. It increases going to the right and down the periodic table. So I don't really memorize the whole periodic table, but what I do know is that H is on the top left. You have boron, you have carbon, nitrogen, oxygen, and fluorine. And I would probably remember the one below that. So you have aluminum, you have silicon, you have phosphorus, sulfur, and then chlorine. For the halogens, you should know as well. So this is what you really need to know for the whole year. So this is the trend that we really care about. These are the atoms. So hydrogen has the lowest atomic number. And then as you go to the right, it's a higher atomic number and down the periodic table. Okay, so this is the trend that you should be familiar with at a minimum. Otherwise, you should pull out a periodic table. If you have it, look at the back of your textbook or pull a card or sheet out and print one out for yourself. Okay? All right. Now, how it works is the higher atomic number wins. Now, if it's the same atom, like for example, let's kind of go through that right now. So here's my chiral carbon. Now, if you look closely, directly attached is a carbon, a carbon, a carbon, and an H. Now, out of all the differences, there's only one, because these are all carbons so far. That means that they have the same atomic number. So far, H loses. It's number 4. See, H is always going to be number 4, always. It's never going to win. It's always going to be the lowest priority. So in our case, we figured out number 4, but we don't know about 1, 2, and 3. So the rule says that if you don't know because it's the same atom, then move out to the next set of atoms and figure out who has the higher atomic number. That's what we're going to do. So if I look, what does this carbon have attached to it? If you count all 4 things that are touching it, it's got a carbon twice, right? Because this carbon has on the left and the right side a carbon. So that's 2 carbons. And it has 2 H's. What does the bottom one have? It has 1 carbon, the chiral carbon, and then 3 H's. So carbon and 3 H's. What about this one? See, here's the rule over here. You count double bond twice and triple bond 3 times. So notice that this carbon is touching a double bond. So that means 2 carbons. We count it twice. Whatever it's double bond to is counted twice. If it was O, it would be O 2 times. So this has 2 carbons and then one carbon over here, and then it also has an H, which you don't see, but we know it's there to make 4 bonds. So here's the difference. So how do you figure out who's going to win? Here's what you do. You look at the things that are the same and cross them out. So there's 1H, 1H, 1H. Now, the fact is that this has, and if you cross out, this is a carbon and a carbon, a carbon and a carbon, and a carbon. So notice that when you cancel things out, this down here only is left with H's. And this one is left with H. This is left with a carbon. So out of these 3, which one is the best? Could you figure that out? The top one. Because this still has a carbon when you cancel the things out that are alike. This is actually number 1. That's the best. But now how do you know between these 2? Well, here's how it works. Notice that this one here, if I did the same logic, okay, but just between the top and the bottom. Let's cancel an H for an H, and then another H for another H, and then a carbon for a carbon. So notice that this one up here has a carbon, and this does not when you cancel out the like things. So this has a winner. This has a C, higher atomic number than below. Notice how I'm doing this. It's not about adding up the atomic numbers. It's whoever has the highest atomic number wins. When you have similar groups, you cancel out the ones that are alike and figure out what's left. So the one on top wins to the bottom. This is number 2, and this is number 3. Do you see how I did that? Okay, so again, just to begin, these were all carbons, so we had to figure out their difference. The fact that this has more carbons than the rest of them, it's going to win because it has an extra carbon over the other 2. So we could have just known that in our mind and moved on. So this has 3 C's, this has only 2, this has only 1. 3 C's is going to win over 2 or 1. And then you just figure out from the leftovers, just cross out the common ground and see what's left over. Whoever has the atomic number that's highest wins. And that's it. So that's how you do this. We're going to learn there's more ideas in here. So for example, if you have isotopes, carbon 13 versus carbon 14, the heavier isotope wins. So deuterium beats hydrogen, for example. So for isotope, you have to know H, D, and T. So this is increasing priority. So H is having only atomic number of 1. D is atomic number 2, and tritium is atomic number 3. Carbon 12 and carbon 13. Okay? That's also with 13 wins over 12. And you'll see others like oxygen 16, oxygen 18 wins. So when you're having different isotopes of the same atom, the heavier atom wins. The one that has a bigger number wins. Okay, so that's it for that part. Now look at number 3. Here's the rule for number 3. Here's how it works. For number 3, what we're saying is that you should figure out from 1, 2 to 3 which way it goes. Like watch, if I look at this right here, 1 is on the right, 2 is above to the left. So here's 1, here's 2, and notice how 3 is down below to the left. So here's 3. So all I did is I looked at my numbering that I put up here, and I just ignored the molecule. I looked at 1, 2 to 3, and I drew it out for myself separate from the molecule so I don't destroy the molecule. Now, when you go from 1, 2 to 3, connect your dots. So from here, it's 1, 2 to 3, and then go back to 1. Which way are you going? So think about it. When I go this way, go all the way through, follow through, like that. What's happening? I'm going counterclockwise. So from 1, 2 to 3, I'm going counterclockwise. What does that mean? Well, for now, what that means is that it's the S configuration. That's rule number 3. So we're guessing. This is called our guess. So our guess is that we're looking at the S configuration. So that's our guess. Our guess is S. Now, is it true? Is this really S? Here's the last rule. So now in your book, and a lot of people tend to teach where you have to reverse molecules in space in your mind. I don't like that. So for a very long time now, I've been teaching this model, this rule. And I came up with this about 10, 12 years ago. I came up with this rule, and people love it to this day. Here's what you do. It just takes a minute to get used to it. So right now, you realize that your priorities is 1, 2, 3. You realize that when you connect the dots, it's going counterclockwise instead of clockwise, right? And now we're looking for true or false. The way it works is you look for your lowest group, number 4. If number 4 is on the wedge, or whatever bond is across from wedge, that means false. Your guess is wrong. Whatever you guessed, it's the opposite. But if your lowest group is on the back bond, or whatever bond is across from the back bond, meaning look at this, always choose solid bonds. So it's either back or the solid bond that's furthest away. Notice how this one's right next to it, further away. So if the lowest group is on the back or across from the back, then it's true. Your guess is true. So this is how you validate your guess. So let's take a look. So we're guessing from 1, 2 to 3 that we're going counterclockwise. Notice that when you're doing this clockwise, we don't care about number 4. We ignore number 4. Just figure out where 1, 2, and 3 is. That's all you care about. So we know it's counterclockwise, but notice that my lowest group is on the wedge. My lowest group is H. It's on the wedge. So the lowest group is on the wedge, which means what? That means false, right? Based on my diagram, false is the position of my lowest group. So our guess is wrong. That's what this means. This is not the S configuration. It's the opposite. It's the R. So the answer is that this is the R configuration. So that's how it works. Now, the benefit of this rule is that it doesn't matter where they draw the lowest group. It doesn't matter how complex it is. All you need to do is follow my rules. Once you prioritize, you number 1, 2, and 3, you figure out, is it clockwise or counter? Clockwise is R, counter is S. And then you prove if your guess is true or false by looking at this diagram. That's it. That's how this works. But obviously, you got to practice, right? Right now, you're like, whoa, what? It's a little cloudy, but watch and learn. And you're going to feel very good about this. So let's do a few examples together, and then you're going to do on your own. So let's take a look. So the first thing here is I have a chiral carbon right there. And if I look at the atoms directly touching that red carbon, it's a carbon, a fluorine, and an H. Well, H loses, lowest atomic number, 4. Fluorine is the highest atomic number. It beats carbon, number 1. Now we have carbons, right? So this carbon on the left has what attached to it? It has 2 H's and 2 C's, right? So this carbon has 2 carbons and 2 H's. This carbon has what? 1 carbon and how many H's? 3, right? It's a methyl, has 3 H's. So if I cancel 2 H's for 2 H's and 1 C for 1 C, notice who wins. The left wins. The left has a C, which is a higher atomic number than an H. So this is number 2 and this is number 3. So now I've got my numbers set. What do I do next? Well, I'm going to draw my numbers relatively located. It's down below, that's 1. To the top left is 2. And to the right side of the molecule is 3. Ignore 4. We don't care about 4 right now. So this is going from 1, 2 to 3. It's going clockwise. So this is our guess is R. That's the guess. So we think this is R because it's clockwise. But now, where is the lowest group? Number 4 is in the back. And if you remember our chart, here's our little diagram. True for the back, right? So we know that this is true. This is in the true position. So the answer is true. Yes, this is the R configuration. If it was false, it would be the S configuration. But in this case, it's true. And that's it. That's how you solve this problem. Do you see that? Okay, now I want to tell you something, a little trick. H is always the lowest atomic number. Then a methyl is usually the next one up. So if you're comparing carbons, a methyl is going to lose to all the other carbon types that are out there. So that's just a quick way to realize. Okay, and I'll show you how we're going to use that here. So by the way, we already labeled this next one, right? It's the same drawing. I flipped it around in space now. So here's 1 for fluorine. Here's 4 for H. Here's 2 for ethyl and 3 for methyl. This is exactly the same as this right here. So we already figured out the priorities. So going from 1, 2 to 3. See, notice how it's top right, top left, and then down below for 3. So we're going counterclockwise for S. And since the lowest group is in the back. The back means true. This is true. So this is the S configuration. So what is the relationship between A and B? They're enantiomers, right? They have the same exact formula. They have the same connections, but they're opposite configuration. It's like a left and right hand. It's R and S. Do you see that? Okay, let's try another one. So now, if you look closely, there's only one possible place for chirality right there. That's the only carbon, because the rest of them either have double bond, and that's out, or they're having too many H's. Like these have 3 H's, 3 H's, 3 H's. So they're all out. So we really come down to, and by the way, this right here is a methyl, right? So 3 H's. It's out. So it comes down to the one I highlighted in red. So looking at this right here, let's kind of figure out the priorities. Number one, the directly attached atom is that carbon, and that. So, and then an H. H is the loser, number 4, right? It loses to carbon. Now, remember what I said. If you remember this, it's going to save you a lot of time. Methyl is always going to lose to all the other carbon types. So this is number 3 because it only has H's and the rest of them have other things on it. So now we're down to the top 2. So what does this top one on the left have? It has a carbon and then double bond. So that means 2 more carbons. So carbon 3 times. And then it has to have a 4th bond, so it must be an H. See that? So this is a double bond carbon. It's 2 carbons and then 1 carbon here. So that's how I got 3. What about this one? The same thing, right? It's got a carbon on the left and then double bond, so it's 2 carbons. So carbon, 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 H. So far, they're the same. They're going to cancel out. So there's no difference yet. So we've already tried the carbons directly touching, and they're the same. So then we try what they're touching, it's the same. So what do? You move out to the next set. So now I'm going to move out to this one and compare it to that one. And right away I see the winner. There's a BR. BR is a higher atomic number than anything else on the left side, right? So let's go ahead and figure that out. So there's 3 carbons and an H. I'm sorry, 4 carbons. There's 4 carbons, because look, this carbon's double bond, so that's 2, and then another 2 carbons. But this one has 3 carbons, but a BR. So the fact that it has a BR, it wins. See that? So the right side beats the left side. But is it better than below? Yeah, sure. 3 and 4 below. So now we know that this is the 1 side, this is the 2 side, and then down below is 3 and 4. So 1 to 2 to 3 is all I care about. So relative speaking, 1 is on the right, 2 is on the left, 3 is below. So going like that, it's going counterclockwise. So my guess is that this is the S configuration, right? So far we have the S configuration, counterclockwise. But notice that the lowest group's on the wedge. And wedge in our diagram means F, false. It's false. So even though we guess that this is S, it's actually R, because this is false. So that means that this configuration is R. It's the R configuration. That's the answer. So this is the R configuration. So we did our configuration. We tallied it up. We figured out who's better than who. Counterclockwise for S, but the lowest group is in the wrong place. It's in the wedge. It should be in the back, but it's not. So that means it's the opposite. It's R. Okay, so now...